Hello, everyone. Welcome to another Directions Mag Geospatial webinar, today sponsored by our friends at Precisely. I'm Barbara Duke, Editor-in-Chief here at Directions Mag, joined by our webinar producer, Lynette Qualia. We encourage you to read the latest geospatial news, articles, listen to podcasts, and of course, watch more webinars at directionsmag.com. We are excited to have Tim McKenzie with us today. We're going to learn how to organize and manage address data, enrich addresses with standard and dynamic attributes, and analyze enriched data and create dashboard visualizations. Welcome, Tim. We are very excited to learn about these things and get started.
Absolutely. Thanks for having me. And thank you all for joining me today. And as Barbara mentioned, we'll talk about how to make your artificial intelligence and machine learning workflows a little bit better. So if you've been around business, which I assume you all have over the last few years, you increasingly hear more and more about companies leveraging machine learning, leveraging artificial intelligence to make better business decisions or to gain new insights into the business that they're running today. Increasingly, as users begin to take advantage of machine learning and artificial intelligence they're learning that, hey, the more attributes I bring to a model, the richer and deeper and better that model will be. And the exciting part for all of us who are in the location business is that location is a fantastic avenue to bring new and interesting insights into machine learning and artificial intelligence solutions. And that's what we're going to talk about for the next 25 minutes or so. So if we think about location, one, just as I mentioned, all kinds of attributes that can be derived from once you understand location. And all those attributes combined together can really provide an interesting set of data that can be analyzed to gain some insights. However, all of you who have been in the location business know that location data has its challenges. Location data can be messy. You know, addresses never are the same. One person's version of the right way to show their address looks completely different from someone else's. Latitudes and longitudes, shapes on a map, different formats, different providers of data. And then when we start to think about how to use this data from a global perspective, thinking of and acquiring data sets that kind of act the same way and look the same way across the globe becomes even more of a challenge. And I think most of the folks on this webinar are folks that are in this business. So you guys know location well, you know the challenges of working with data and location, and you've probably figured out a lot of workarounds in order to make location data do the things that you want it to do. But if we think about this new era of machine learning and artificial intelligence and the increasing reliance upon data scientists by companies and looking to data scientists to deliver new insights to the business that actually change the way that they're doing business, they don't always come, a data scientist doesn't always come from a location background. So if we think about, in general, data prep for a data scientist is a large part of their work, and most would say, hey, if I could get more data cleaned up front, I get to do my job, the job I like to do, quicker and faster, and become more and deliver more insights to my company. And I think they would echo that concern and maybe multiply it by 2 or 3 when they think about location data. So if you think about a traditional data scientist is used to working with rows and columns of data, data that can be easily ingested into a model, data that can be, analytics can be applied so that you can gain some insights, and then they're handed a map or a set of shapefiles or a set of latitudes and longitudes, and trying to figure out how to turn that data into some sort of table that they can then use in a model, oftentimes can be challenging. And so we at Precisely began a journey, I'd say probably 6-7 years ago, to try to make this process a little bit easier, a little bit, I guess, really address the concerns of the last couple slides. So making the challenges of using location data a little bit simpler, making location data more accessible to a broader set of users that may or may not necessarily be GIS experts. And our strategy really falls into these three categories that you see on the slide. So one, organize. So how can we organize data and convert location data into rows and columns so that a traditional analytics engine can take advantage of the data. And the first step is to organize the data against a trusted location ID. In our case, we tend to approach location from the perspective of an address, and our IDs associated to addresses are unique and persistent, so that we can start to use that unique and persistent ID related to an address as a foundation for appending data to that location and then ultimately applying analytics. So from our perspective, organizing data starts with an address or a lat long and then deriving a unique and persistent ID for that location. Secondarily, we as a company provide about 9,000 attributes for any location, and we provide that data, have done it for 20 years as spatial files, but over the last 5 years have begun to provide these attributes as a series of tables, again, organized back to our unique and persistent IDs. We'll see towards the end of this session a demonstration where we actually put these tables to use to show how we can enrich locations with a variety of attributes. But I guess the second concept around enabling data analytics for location is around enrichment. So making enrichment easy so that you can take a set of locations and append a lot of data to those locations so that you can begin to do the fun part, which is analyze. So we all are familiar today, I'm sure, with the cloud and the opportunity that the cloud brings. And so enabling cloud technologies to operate at scale so that we can begin to gain and draw out insights from a location perspective to drive models and predictions and scores that can ultimately drive business by using cloud-based technologies to operate at scale is really the third foundation of what we believe is a strong strategy for bringing location data into these fun new applications for analytics. So if we go back to the first one, which was organize, we've developed it within our geocoding solution, a capability which we call master location data, which we're within a targeted set of countries compiling a best of breed geolocation data set that has at its core what we call a precisely ID, which is a unique and persistent ID for every location in that country. So picture in the US, for instance, a little over 200 million unique and persistent IDs that speak to every known location that we can find here in the US. And then a set of metadata that talk to the quality of that location. And then when we say genealogy on this data set, so an organizational structure to talk about parent IDs. So when we think about multifamily housing units, or we think about commercial properties where you have a base address and then you have subunits associated to that base address. So we built, a relationship table between those base addresses and subunits so that you can easily understand the number of units within a building. You can see in the middle the countries that we've covered so far. And then behind that, we have our global geocoder, which would cover the rest of the world with your traditional geocoding technology, which would take an address and relate to a latitude and longitude, or take a latitude and longitude and relate out to a address itself. So once data is organized to this precisely ID structure, the next step is to begin to enrich that address with location-based attribution. And so these are some examples of the types of data sets that we provide at Precisely. Unique set of data attributes that tend to solve a variety of questions around commercial locations. And then certainly what we're here to talk about today is how do we create our own attribution and how do we use that effectively to drive out business insights. So thanks for that. So going back to our data sets that we offer, so I think I mentioned at the beginning, roughly 9,000 attributes that we can append to any given location. Kind of falls into these general categories: addresses and properties, so listing of every address within a country, by descriptions of the property itself at each of those addresses. Boundaries could be anything from administrative or community or neighborhood type boundaries to more of activity centers. So creating boundaries that would describe generally what would occur in that area. So residential versus retail versus industrial. And then demographics, a whole host of demographics products that describe populations within a given area. Points of interest, where we would also have our commercial properties. So this would be what we think is a fairly unique data set in the marketplace. We have a data set of over 300 million global commercial and points of interest locations, and we can talk about that a little bit later. Street networks and risk. We'll talk actually about risk when we get to our demo here in a second. From our perspective, our enrichment business is an important part of what Precisely offers to our customers. It's a deep catalog of data sets that are curated specifically by us to connect to our Precisely ID, to make it easy for our customers to acquire our data, join it together, usually in most of in common data platforms like Snowflake or in the Amazon Marketplace or in Databricks, and we'll talk about that some more in a second. But we make this data available in a wide variety of marketplaces so that you can easily get the data where you're doing the work. In terms of, I guess, if you think about the three pillars that we talked about at the beginning of the strategy: organize to Precisely ID, enrich with a deep set of data attributes. Last was analyze. So we bring to bear a variety of technologies that are all cloud native that provide, you can see, a variety of different functions that we provide to run natively within cloud architectures to enable our users to do things at scale, to use data where they have the data, which tends to be in the cloud these days, and to take advantage of common cloud native technologies that are available today, like Spark and Kubernetes and Python. List goes on and on, leveraged on platforms like, as I mentioned before, Snowflake and Databricks. So what's this look like when we start to bring this data together in your environment? In this slide, we're taking a banking type use case. If you look at the left, input sources of data that you might have within your organization that you're ETLing or you're bringing into one of these new modern data platforms like Databricks or Snowflake, or we'll actually show a SageMaker demo here in a second. We've run a geocoding job to take the location data that you're bringing from, let's say, customers. So what's the customer's address? Assigned to a Precisely ID using our geocoder. What about web visits? Grab those addresses, assign them by to our geocoder to Precisely ID mortgages, and you can go from there. The idea though is to bring, as every piece of data is coming into these platforms, we would organize that data by the Precisely ID. Then you can easily enrich it with our portfolio of data assets, which are the things at the bottom, which again, we reviewed that a second ago. So all those data sets are you're able to join those to your input data sources just by a join by Precisely ID, with the ultimate goal of applying some sort of analytics to get to the use cases that you see on the right-hand side, which would be to enable data scientists to have machine learning with dashboards that you can easily explain the insights that you've derived, to real-time applications that are driven by scores against addresses for things like, for your actual real-time or transactional type use cases. When we think about this, so that's good in theory. Now, how do we make it actually work? So the challenge is, how do you find the right sources? If you think about the slide before, how do you find the right sources on the left to feed into your centralized data repository so that you can start to make the kind of decisions and gain the kind of insights that your organization's asking you to find? And then how do you set up a process to adapt to the changing data that would come in on any of those feeds? How do you leverage the data and leverage features that you can create to build training data sets that ultimately power production-based data insights? So that's the challenge at hand. We tend to see our customers taking what we would call a feature-based architecture, which is designing a flow of data into these cloud environments that enables them to create a deep and rich feature store that has, I call it a library really of candidate data sets that can be used by data scientists or analysts to then build new data insights and build new scores, build new processes internally to drive business, with the idea that as new users come into play who are creating new scores or new attribution, they may be checking out some features that are already in the environment, but then they're checking in features that they've created, so that we create this concept of a feature store where various users within the organization can take advantage of the insights that one person created, to then take those insights and use them now as a attribute for a new model, so that over time an organization develops a deep and rich catalog of features that users across the organization can take advantage of. And if you look at this architecture diagram, you see at the top the idea of data flowing into this environment, then creating a compute layer in the middle where this organization and enrichment occurs, and then an analytics layer that then drives into analytics platforms to then ultimately derive insights. I think from here, I think I'll jump over and show a little bit of an example of this in action. This screen, you may be thinking, what in the world is this, and what are we showing here? So I'm going to show a little bit of tech, and then I'll show a dashboard at the end that puts some shiny on the technology. So this is actually Amazon SageMaker, and we run a lot of processes, and our customers use SageMaker a lot to build actionable insights with our data sets. And in this case, I guess the scenario set up here would be a property and casualty insurer who is concerned about the threat of wildfire to their book of business, and so they have asked their data science team to create a dashboard that helps the executives within the organization better understand the threat of wildfire on their book of business. So in this case, this particular data scientist has taken in a file of claims, historical claims that have been filed as a result of wildfire incidents. They've ran them through Amazon EMR, Elastic MapReduce, using our geocoder to assign a precisely ID, which you see that, a precisely ID to each of those claim records. First step they did was join those claim records to our wildfire data. So we have a wildfire data set, which is a nationwide model that predicts the risk of wildfire for anywhere in the country. So in this particular model, they first joined all these claims to our wildfire data, and then joined them to our construction data. So in this case, they've chosen building condition data, building construction type, the exterior construction of the building, the roof shape, the roof coverage, and the roof type, and then basically built this into a single data set. And if you think about what I just said in a minute and a half, if we think about building or going towards this with a traditional model, or traditional location model, we'd first do a geocode step, obviously, to get a latitude and longitude. We'd probably then do a point and polygon against a parcel data set to get a address parcel number. You'd then take that address parcel number and try to join it to an associated county's county assessor type data set to then derive all this data. In this case, though, we were able to just join by precisely ID and build this data set really quickly with limited amount of spatial know-how required. From there, we take this data source that we just built and we pull it into the modeling component within SageMaker. And in this element, we're actually able to tell SageMaker a little bit of what we'd like to do, and then SageMaker goes at the business of doing it. So in this case, we've told SageMaker we want to take 80% of this file and build a training data set. We want to train the model, and then we want to test and validate the model against the last 20%. We've told SageMaker build 20 models and pick the best performing model, and go at it. And so in this case, we took the target data set, SageMaker then trained the model, and then ultimately used its processing power to spin up a cluster and run 20 different machine learning algorithms against this data set, the training data set, and then validated it against the remaining 20% to then pick the highest performing model. So this was just a quick run, and in this quick run, came back and said that it's roughly at a 68.5% accuracy within the model. And we use those results. So we use these results to then apply the insights of this model. So the insights of this model being, does this house fall within a high-risk area for wildfire? If so, what are attributes of the construction that might be indicative that this house would eventually burn and file a claim? So in this case, now we switched over to Databricks. And in Databricks, we're using a few interesting things here. One, we have a dynamic weather product, which is a solution of ours that ingests weather related activities, either predicted weather or real-time weather, up to the minute real-time weather, or historical weather, all organized against our precisely IDs. So as long as you ingest into our weather API your list of precisely IDs, you can then pick, do I want predicted weather, do I want real-time weather or historical weather? And then the dynamic weather product will then provide insights related to the given precisely IDs. In this case, we're asking dynamic weather to give us weather predictions, specifically around fire risk. So understanding, I would think humidity, dryness within an area, wind related to an area, and then use that plus the scoring that we had before, plus the building construction type, to then create a prediction on the properties that are most at risk of wildfire in this particular case. And so to us, the value of these, what were somewhat ugly code-related steps, are when we can derive and get to a view like this that speaks to an executive audience, that can give insights that an executive audience can take advantage of and take action against. This is one example of many, of course, but the idea here is, as I've mentioned throughout this webinar, is let's make the concepts of location enrichment easy to do in a scalable environment, so that you can ultimately drive to insights that can change the direction of your business. And that's it for today. I think from here we'll switch over to some questions.
Absolutely. So we have a few, and we'll just remind folks that we do have a few minutes here, and if you still have a burning question that you wanted to type in, just do that at any moment. What are examples of calculated attributes that you have seen customers create using your data?
Yeah, sure. That's a good question and a fun one. And it's kind of hard to think of the best examples because we've seen a lot. So one that I think of a lot is in the real estate business, especially in mortgage. Mortgage companies are trying to make sure that they understand, if it's single family homes, they want to predict out the value of that home based upon lots of categories. If it's a apartment complex, they want to predict out the sustainability of rents or occupancy. And so one interesting set of attributes that we've seen is the concept of amenity scores. So taking properties and then using our street routing engine, and if it's in a complex city, might use from a walkability perspective, or if it's in a more of a rural or residential area, the driving calculations, and then grab all the business locations within easy access or easy travel to that area and create scores. So if it's, for instance, like say a high-rise apartment building that's fairly expensive in Manhattan, let's create a score on the ease of or accessibility of fancy coffee shops and high-end shopping and maybe nice workout facilities. If it's more of a distressed area, a mortgager might create amenity scores to better, to score a property based upon accessibility to public transportation, to food sources, to medical care, things like that. Others we've seen in the telecom industry, serviceability, so predicting the ability to get signal into a building based upon the type of property, the construction type, and then based upon the signal transmitted from the telecoms network. Others, insurance, like you just saw. So interesting thing in the insurance industry that we're continuing to see is more and more insurers are looking to build what I would call a digital twin of every address, say in the United States, by a series of risk attributes so that they can have a pre-built model for every address, just waiting really for one of us to say, hey, we'd like some insurance, so that they can automate the process of underwriting that property at speed and accuracy.
Cool.
Any other questions, Barbara?
Yeah. We've got a couple more.
Okay.
How is your ID different than Uber H3 or GeoHash?
Okay. Yes. So all are good IDs, and I would think of Uber H3 or GeoHash is maybe a little bit different than our Precisely ID. So I think, as I mentioned at the beginning, our Precisely ID really is tied to an address. So whether that's an address of a large farm, a 50-acre farm in the middle of Kansas, so there's an ID for that address at that farm, or it's for multiple subunits in a high-rise apartment in downtown Manhattan, will have a unique and persistent ID for each of those addresses within those properties. On the other side, things like H3 and GeoHash talk about areas. So they're not necessarily caring about the addresses that fall within that area, they're caring about a shape on a map. Both have their use cases, both are incredibly valuable. If you think about, like, for instance, the wildfire data that I joined in this demo, that's shapes on a map. H3 is great for that. If you think about property attributes, so the construction type, which is at a property level, and my house is made differently than my neighbor's house, so you really, in that case, the value comes in having something like an address-based ID. So address-based ID versus location-based ID.
All right. And one more question. What are the most popular U.S. data sets that you provide?
Okay, yeah. So we have a lot to choose from. I think today the most interesting one that we just released it probably about 9 months ago. It's called our property graph. And so property graph actually takes Precisely IDs, so address locations, and then creates a linkage to building IDs. So picture, my house at my property, so my address tied to the building ID for my house, tied to a parcel ID, tied to ownership information, tied to business listings. So in the case of my house, that really wouldn't matter, but we think about a commercial property, which maybe has one big parcel, maybe 3 buildings with 20 tenants on each. This property graph would help you better understand the number of buildings on that parcel, the total number of potential tenants, then details on each of those tenants, and then ultimately the owner of all those properties. So it's got all kinds of use cases across all kinds of industries, and it's really been growing a lot over the last, I'd say, 6 months.
That's great. So if folks want more information, is there one particular spot to go?
Yes, so precisely.com.
Okay. Thank you again, Tim, for sharing your expertise and all the great things today. A little shout out to Kim and Ty for their help behind the scenes as well. Go make it a great day. Tell a friend about Precisely and Directions Magazine. Thanks, everybody.